Hello everyone, welcome to the Go Code Snippets channel. So in today's video we'll be looking at how to create a basic cryptocurrency wallet. So a basic Bitcoin, let's just say Bitcoin for example, a basic Bitcoin wallet. So before we jump into the video, I'll first like us to do a 10 seconds commercial break. So for the next 10 seconds, if you are new to the channel, please subscribe, and if you've also been watching videos but you haven't subscribed, consider subscribing. So 10 seconds. So if you subscribe to the channel, I really appreciate it, and if you haven't subscribed, please do. It will just take you just one click. So with that, we go into the video. So all we'll be doing in today's video basically is we'll be having a type wallet. So this type wallet will be having three fields: a public key, a private key, and a wallet address. So basically these fields, don't worry about what they are. As we move into the video, you understand what they are more. So the public will be of type ECDSA public key, and private key will be of type ECDSA private key. So ECDSA generally the full is actually the acronym for elliptic curve digital signature algorithm. So ECDSA, elliptic curve digital signature algorithm. So basically this is one of the numerous algorithms used in cryptocurrency and blockchain development and all. So now, but actually this ECDS actually is a very complex algorithm, but thanks to the Go programming language and the standard library, there's actually a package ECDS in the standard library that actually helps us manage all those complex maths and does use those functions that we can just call and to do all the complex maths for us. That's one of the numerous advantages of the Go programming language. Like the standard library is very, very powerful. So it's going to have a wallet address, which is basically a string. So we'll just be having just one function, new wallet, which is basically this function here. But before we go into this function and see how we actually create a new wallet with this function, because this function just generally returns a wallet for us. So before we actually go into it and see what it does, I want us to actually look what is in this URL. So you can visit this URL later, and you can just pause this video and just check this URL out and visit it. But I'll show you what it does. So in my browser here, I've actually visited the URL, and this is it here. So this URL is just basically the technical background of version 1 Bitcoin address. So it's just like a documentation, like a document that you can use to just see how Bitcoin works under the hood, basically some basic stuff about Bitcoin. So here we have how to create Bitcoin address. So all these steps here, step 0, step 1, step 2 up to step 9. So these are the steps that I actually copied and I just pasted them as comments in my code. So those are the steps we'll be following. So that's basically what I have here. So are the steps we'll be following to create our own wallet. I'm moving too fast. Let me just do this. So those are the 9 steps I've actually highlighted here. So I just copied them and I pasted them here. Well, one thing I actually like to mention before we actually go on is if you look at here, this step 1 and step 2. So step 1 says having a private ECDSA key, then take the corresponding public key generated with it. So basically I'm just merging those two into my own step 1. That's why I don't have the step 0. So that's it. So we'll be following these 9 steps to see how we can actually create our own wallet. So with that we move. So the first step says creating ECDSA private key has 2 bits and a public key 64 bits. So how do we go about that? So it's very simple. So what we just simply do is that we'll do a private key. So if you look at this package crypto ECDSA, so in my browser here, package crypto ECDSA. So if I just check the examples and I check the package example, so I have this example here. So this example here is exactly what we'll be doing. So using this example to generate a private key. So we are just copying this particular example here. So I can just copy it. Let me just copy it and paste. So that is going to save us a lot of typing time. So that's the first thing. So to generate a private key and a public key, we'll be using this function. So just highlight the code. Then I'll set my wallet's private key to this wallet. So first of all, I made a mistake. I'm actually supposed to declare a wallet variable. It needs to be a pointer to a wallet. So I'll do w dot private key should be equals to this private key. That's the first thing I'll do. Now we need a public key because it's only a private key we have. So back in my browser, if I check for this here, it's actually func generate key. So func generate key is down here. If I click this function, it's returning a pointer to a private key and an error. So as it comes, private keys actually come as a pair. So once you have a type, private key actually comes as a pair, and the second pair is actually the public key, which is a field in it. So I just simply do w dot public key public key should be equals to w.private key dot private key dot public key. So if you notice, we're having an ampersand. Why are we having an ampersand? This field public key is actually just, so if you come back to the browser, this field public key is actually just a type public key, not a pointer. And what we want actually in our addresses, in our wallet, is actually a pointer to a public key, which is what we want here. So we have to put an ampersand to make it a pointer. Simple. That's the first step. So we are done with the first step. So the second step now is, so the third thing, which is the last thing we need now, is we have our private key and our public key, but we need a wallet address. So all the remaining steps is just towards creating a wallet address. So the next step is actually to perform a SHA-256 on the public key. So to perform a SHA-256, if you check our, so back in my browser, if I check crypto, and SHA-256 is actually from package crypto / SHA-256 is also from the standard library. So under very great reason why Go is actually good for blockchain development. So everything, most of the functions you've been needing, or most of the functionalities you've been needing, a lot of them are already in the standard library. So hardly will you use something outside. So with that, enough of the talk, let's continue. So it's from crypto / SHA-256. So I've actually opened the package here in my browser. So if I go to my examples, for example, and I check example for new, so it's actually how you create an hash with SHA-256. So you say h equals SHA-256 new, then you write a slice of byte into it, then you are just printing the sum as an hexadecimal. So this is basically how it works. So I'll just copy this code here, and I'll come to my browser and my text editor rather, then I'll paste it here. So I'll just do some formatting to this side. So here, instead of me writing hello world, remember what I want to hash is the public key. So I'll just be putting into this place w.public key. But if you look at our public key is actually of type ECDSA public key, but what write wants is actually a slice of byte, because if you notice, it was slice of byte hello world that was passed into it. So how do we get a slice of byte from our public key? So it so happens that our public key actually has a field x, and that field x, and that field x has a method byte that will return a slice of byte for us. So we'll just call this method byte on it. So we have a slice of byte. So just to confirm that, we'll go back to this place, then we'll check back in our ECDSA. We have a public key, it has a field x and a field y, and they are both big ints. So that is type int from package big, and package big is match4/big. So if you check type int from package big, we have a particular method byte. So let me search for that byte. So this method byte returns a slice of byte. So that's basically what we are calling into our write method for the hash. So we'll be doing this for both the x. So if you remember, our public key has an x and it also has a y. So we're doing for both the x and the y. So back in our browser, if you remember, our public key has a x and a y, and they are both big ints. So we have to hash for the x and also the y. So that is it. So that's how we do it. Then from here, we don't actually need to print it because we actually need the hash. So we just assign this to a variable, and we just say hash1. Let's say hash1. Hash1 should be equals this. So that is it. So we've gotten our next step. So the third step now says perform a RIPEMD 160 hashing on the result of SHA-256. So RIPEMD also works the same way with this also. I'll just simply copy this and I'll paste it here. So it works the same way with SHA-256. So instead of SHA-256, I'll be having RIPEMD 160, which is this .new. So I'll be renaming this one to h2. Then I'll do h2.write. And what do we want to actually hash? The result from the SHA-256, which is h1. So I'll be doing this. Then what I'll be having here is h1. I don't need this line because the reason I want to hash is h1, and I'll change this back to h2. So this one will be hash2. So we are done with this next step. So h2 should be equal to, why am I getting an error? Let me format. Okay, no error. I was wondering why I was having an error. So here we have our second hash. So we are done with step 3. So the next step now is step 4. So step 4 says add version bytes in front of RIP 160 hash. And basically what a version byte is just a byte. So the version bytes for the main network generally is 0x00. So remember that we want to add a version byte to RIP EMD or RIPEMD 160, and RIPEMD 160 is actually giving us 20 bytes. Then we're adding 1 byte, that's 21 bytes. So I'm actually going to make a buffer, and that buffer is actually going to be a slice of bytes, and the length will be 21. So basically this is 20 from RIPEMD 160 or RIPEMD 160, and one from and 1 version byte. So that is 21. So the next thing that I said, so the instruction says add version bytes in front of it. So I'll just say the buffer, since I'm adding it in front, into bracket 0 will be equals to the version byte, which is 0x00. That is the version byte. Then I'm adding this in front of the RIPE EMD 160, which is this hash that we got from here. So I'll just simply say buff. So I'll say copy. Then I want to copy from the second to the last, because what I'm adding is in front of this. I've added the version bytes, so the remaining will just simply be our hash 2. So that is the next thing. So we have our buffer. So the next thing says perform Shuttle 5 on the extended RIP RIP EMD 160 result. So I'll just simply copy back. So I'm actually performing a Shuttle 5 again. So I'll copy this line again and I'll paste it here. I'm sorry, I'm doing a lot of copy and pasting. So if you're not actually using a linter or you're not using the plugins that will give you warnings, you probably shouldn't copy. So write out the code and figure out the bugs. So I'll name this one H3. So we've used H, we've used H2. I'll name this one H3 to be Shuttle 5 name. So what we want to do is we actually want to perform the hash on these results that we got here, which is basically our buffer. So I'll just simply pass in my buffer here, buff. So this one should be H3.write. So let's make sure we're not making any mistake. Then this one should be hash3 and go to the H3.sum new. So that way we are having our third hash. So from there, so we are doing a lot of copying and creating new slices and all, but just follow and everything will be alright. So from there, say we should perform under Shuttle 56 on the result of the previous Shuttle 56 hash. That means this hash here perform under Shuttle 56. So we'll just copy this. So that means this step and the previous step are basically the same. So I'll name this one H4. Then this one to H4. And what I want to actually write is hash3. So this one is going to be H4. And it should be hash4, H4.something. So we are done with that step. So the next step says take the first 4 bytes of the second Shuttle 56 hash for checksum. So that means this particular hash here, I want to take the first 4 bytes for checksum. So I'll just say checksum. Checksum should be the first 4 bytes. So to get the first 4 bytes, that will just be hash 4 into brackets this, then 4. That's the first 4 bytes. Then says the next step says add the 4 checksum bytes from 7 at the end of the extended RIPE EMD RIPEMD 160 hash from 4. So remember that from step 4 here, this RIPE 150 hash is 21 bytes. Then I want to add these 4 bytes at the end. So we're having a total of 25 bytes. As I'm actually writing 25 bytes here. So I'll just create a buffer. So I'll say buff should be equal to make slice of bytes, then 25. So that is 4 from this checksum and 21 from this RIPEMD in step 4. So that will be doing. So I said, so we're adding this particular one at the end. So that means this 25, the 21 bytes from here comes first, then this 4 at the end. So how do we do that? So we just simply say copy. So I'm using copy buff. So what we're adding first is the 21 from this. So I'll just say copy buff. Then what I'm copying is going to be the RIPE EMD, which is basically this here. Or I'm thinking of, let me call it buff 2, because I already have buff up here. So it's going to be this buffer. Then from here to 21. So why is that? Remember, I'm adding this one first, then this checksum at the end. So that means the 21 here comes first. So I'm copying into buff. Oh, it's meant to be buff 2. I'm copying into buff 2. 21, and I'm copying buff into it. So I'm just basically taking the first 21 space, or the first 21 buff, or the first 21 space from this buff 2, and I'm copying this buff into it, which is what the RIPEMD from step 4. Then the remaining 4 bytes, so I'll just copy buff 2, the remaining 4 bytes, that's 21 to the end, and I'm copying the checksum into it. So don't let this particular step be confusing. This is quite straightforward. So the step just has this 4 checksum bytes from 7. So this is the 4 checksum bytes from 7 at the end. So we're adding it at the end. So that's like the 21st to the 25th. So that's basically 4. And adding it to the end of the extended RIPEMD 160 hash from 4. And RIPEMD 160 hash from 4 is actually 21. So that means this 21 comes first, which is basically what we're doing here. Then the 4 comes last. So this 4 here comes last. This is basically what we are doing here. So that is it. Then the next one, which is the last step, just simply says convert the result from the byte into base 58. So the way base 58 works is you say base 58.encode. So it takes in a slice of bytes, which is basically our buffer, that is buff 2, and it returns a string for us. So we just say str should be equals to this. So that's basically, so this string is basically our wallet address. So we just say w.wallet address should be equals to str, then we'll return w. So basically we've created our wallet, simple and straightforward. So all the steps, if any of the steps is confusing, you can just rewind the video and watch again. So before we move on to the video again, I'd like us to take our usual 10 seconds commercial break again. So in the next 10 seconds, please subscribe to the channel. Okay, so great, we move. So if you subscribe to the channel, I really appreciate it. And if you haven't subscribed, you should consider subscribing. So it will just take you just a click, no more, no less. And also, so far, if you actually like this video, it's actually a chance also to like the video. So with that, we move. So now we have our wallet. So all these functions here are just basically a function that I just wrote before the new function, just to help us get what we need from the wallet. So this first one is able to get our private key for us. That's why it's the method get private key. Then we will get the private key as string. So it's basically just getting our private key, and this our private key has a field d, which is also a big int. And remember that a big int has a method byte that actually returns a slice of byte. So everything here is actually going to return a slice of byte, and I'm putting that as hexadecimal. So and I'm assigning it to a variable. I'm just returning it as an hexadecimal. Then also I'm doing the same thing for the public key. This one gets the public key. Then this one also gets the public key x, which is a big int, as a slice of byte, and it turns that hexadecimal. And it just simply concatenates it to the y also as an hexadecimal. So that's what basically this does. Then the third one is just to help us get wallet address. Just return the wallet address. So I'll just add one more function, which is just a function that will help us print our wallet address. So I'll say wallet. Then it's going to be a print function. So a print method rather. So what it just simply does is just print out 4 things for us, or 3 things, to help us print out the information in our wallet. So I'll just say private key. So I'll do percentage s, and just use percentage v. Then I'll do backslash n because I want an extra space after I print it. Then I'll do w dot to get private key as a string. Simple. And then make it s, since I'm working with strings. So I'll copy this. Print f percentage s. So I'll copy this and I'll paste it 3 times. So what I want here is the public key. Let me put a space here. So it's going to get public key string. Then the last one is going to be our wallet address. So get wallet address. So this is what our print function will be doing. So one more thing I would like us to go through before we actually run the code in our main function is just I just want to actually go through all the packages I use. So this ECDSA here is basically from package crypto ECDSA. So we've seen that. Then this particular part elliptic P256 is actually from package crypto/elliptic. So I'm actually using auto import packages plugin. So I'm using a plugin that actually auto imports packages for me. So if you're not using that plugin, you have to actually import them manually. Then this round here is actually from crypto round also. So you're using a lot of sub packages in package crypto. So then which other one again? Then one we're using for RIPEMD 160 is actually from here. So you have to actually go get this. So this is the package. It's not in the standard library. So whenever I see a package that has google.org/x, so it actually means it's experimental. They're actually planning, Google is planning to put it into the standard library, but it's still experimental for some reason. Maybe they're still doing some testing, and also they are not sure if they should put it yet or not. So whenever I see exam is experimental, that means soon it's going to be part of the standard library. So you don't need to do go get. But if you don't have it, you have to actually do go get. And then the name of the package, which is basically this. So you run this command, and also you have to go get this also. So it's actually an external library that someone has written. So github.com/btcutil/base68, which is what we use down here. And we're actually doing our base 68 encoding, or base 58 rather. I said base 68. So base 58 encoding. So that is basically the two external packages that I think you will be needing. So you have to go get those ones. Then this package crypto SHA-256 is what we're using to do our 256 hashing. So all these crypto packages and all this hashing are actually complex mathematics, but thanks to Google and developers at Google, everything has been written for us and have been hidden under the functions of package crypto. So it's a lot of complex maths, and since this is from Google, is in the standard library, that means it's developers at Google that wrote those packages with help from developers outside, because Go is actually an open source programming language. So you should be rest assured that the codes have been reviewed and there are actually codes that you can actually rely on, or there are functions that you can rely on. So with that being said, we'll just simply create a new wallet. So you can just say wallet should be equal to new wallet. So we'll just do wallet dot print, and we'll just run the code. So I'll format again, then run. I'm not actually use them. Okay, something is wrong. I'm using them actually. Okay, excuse. So it figures that was some random weird error, I don't know. So if you run the code now, we'll be getting this. So basically here is our wallet address, and these are our public key and our private key. So you can run the code again. So every time you run the code, you get a different wallet address, a different public key, and a different private key. So we can run it once more. So basically these are our new wallet address and our public and our private key. So that is how you create a Bitcoin wallet. So with that, I would like to end this video, but before I end it once more, if you are new to the channel, make sure you subscribe, and if you're not new to the channel, you'll be watching videos but you haven't subscribed, please do subscribe. And if you also like the video, leave a thumbs up in the video. And if you also have any suggestions or comments or any constructive criticism, just drop it in the comment section below. I like reading comments just to like improve the channel, because I'm looking to improve the channel, and all, and you post comments can actually put me to the right direction. So that will be it for this video, and with that I will be ending this video.